Right, so let's get started on our day 3 of programming languages. So today we will look at syntax, how we describe syntax of a programming language, and of course in regards to semantics also. So what's the difference between syntax and semantics? And so until now we've seen many different languages. We need to come up with some formalism, some approach how to describe a language, right? We could, of course, do something, come up with something of your own, but there are certain methods, already developed technologies. They arose from, again, some historical background. It arose in 1950s, again, when programming languages were being actively developed, the first ones, Fortran, Lisp, COBOL, and so on, ALGOL. At the same time, there was some development in natural human language. Chomsky, the major figure of the day at the time, right? There was a lot of talk of how human language is developed, and also how you understand what makes up a human language, what makes up a human thought, and so on. All right, so there are certain similarities between what computer languages look like and what human Latvian, English, Spanish, and so on languages look like. All right, again, I'll be using a notebook from this, and again, I'll use Colab again as usual. So hopefully recording is, we have sound, we have pictures. All right, let's connect, see, let's sign in. All right. I probably won't really do much coding today, not yet. All right, let's connect. All right. So syntax. So how you understand syntax of a language? Again, it could be human language, computer language, right? So those are basically rules. So say again, we all got a syntax error when we are writing a program, right? So basically specific rules how you should write your code, your program, right? How to form it. So again, like in Python, I'll make this a little bit bigger so you can see it. You guys see the screen, right? Yeah, right. So this is valid syntax, assuming again, we don't know the variable name, of course, in Python, right? What makes variable name, right? There's certain rules for that as well, right? And a value, it makes a valid value. That's an assignment, right? And we know, of course, the syntax for a for loop, right? You write for some variable, right? And then there's something iterable. Again, whether it's a valid iterable, at the moment we are not making sure, right? It's some iterable, right? It's possible. It's actually not the iterable. Actually, there's no such iterable, right? So again, at this moment, at this stage, we were looking at what missing braces, missing brackets, missing parentheses. If it's an indentation specific language such as Python, right? We're looking for missing, bad indentation, right? Indentation. Infamous indentation error, right? You have maybe an extra space or something like that, right? Similarly, in languages which are heavily semicolon dependent languages, right, which require semicolons, we're trying to see if you're ending your statements with semicolons where you need it, right? Again, so this is what we're looking at. Now, compare that with semantics, which comes later, right? Meaning, right? So again, two different. To make a program, you need both, right? But semantics is a meaning, right? Whether actually this is so it can be the program can be syntactically correct, right? It might not do semantically something that you should be doing, basically. So semantics, so scoping rules, types, expression evaluation, order, maybe incorrect order, right? It's possible, right? So type mismatch, you're adding string with integer. A syntax checker will not pick up on this, right? Adding string and integer together, depending on your language. If it's JavaScript, it might be okay, all right? It's allowed. But if it's Python or maybe C, right? You're not supposed to do that, right? So that's part of semantics, right? But syntactically, right? 5 plus valdis is allowed synthetically, right? So undefined variable, division by 0, index out of range, that's all semantics, right? So they're very closely related, right? So like I mentioned, dividing by 0 is usually syntactically correct. Most languages will let you divide by 0. But how do we deal with them semantically, right? We maybe try catch an exception, probably, right? We have to come up with some means of dealing with it. So again, today we're only looking at syntax, how we determine whether the program is syntactically correct. So if you try and come up with rules for your own language, you will want to, have some way of formally checking this, right? So again, semantics, of course, can be correct if syntax is incorrect, because, of course, you don't get that far, right? So usually most languages, most serious language, I would say, I don't know if you can find me an exception of a language which does not have this formal specification. I would love to hear from you guys. If you find some decent language which does not have a formal specification for syntax and semantics, right? It's kind of hard to do that, because you will need it. Again, if you're writing a compiler or interpreter for a language or something, or some hybrid, right? You will need that. Otherwise, how do you know the language actually is a valid language, right? Somebody writes compiler for your language, and well, it seems to work, but again, if it's all in your head, or if it's all on your piece of, I don't know, of cardboard or napkin, right, and it's just some scribbled notes, right, it's not really gonna make for a good language, right? So, of course, just like with a regular human language, I would like to make an analogy, right? How do we learn language, right? Usually, what's the best way to do it is by absorption, right? We sort of live in some country, right, and we learn the language, right? As a kids, of course, like we live in our native land, right? And that's the best way to learn. So we learn what? Not from books. We learn implicitly, right? Similarly, this is programming, right? When we are programming something, right? At some point, of course, we start maybe using some books, but somewhat, basically, we sort of like, we read documentation. We don't really, very few people read these formal specifications unless you're writing your own language, right? Why? Because they are not, they're quite dry, right? We pick up what language should look like, basically from tutorials, from people teaching, like me teaching or somebody else, right? Examples, basically, right? So okay, so you can look at the program, say, okay, this does not look right. There's some syntax error. And of course, we can also, of course, usually let the syntax errors be handled by your IDE, your editor, right? Your Visual Studio Code or whatever you're using, right, is going to pick up these syntax errors, right? So why would we want to study this, right? Why do we want to study these ways of making this, right? So, well, the thing is, you most likely will not create a production level programming language, general purpose, right? However, if you're dealing with things like natural language processing, right, you have some sort of text, some documents, some information you need to extract, right? If you can come up with some rules how to extract it, it can help. This knowledge of these formal grammars can help. Similarly, there are some language, like again, you can define, for example, syntax, not only for programming languages. You can define syntax for things like XML, HTML, right, JSON, and so on, which are not programming languages, right? But they are markup language, right, or some other language. But we still need to deal with that. Also, communication protocols, right? So you can check for security. Again, you can come up with a language for bioinformatics, right? For structuring. If you're going to biocomputing, right? A big field. I think it's probably the next big thing. It's already been a big next thing for 40 years, right? But after large language models and electric cars, I think bioinformatics is a big developing field, right? So again. In AI, of course, right? You can use a grammar to describe something for a sequence of robots if you want, right? Not necessarily, but it's possible, right? Even in music and art, you can do some grammar-based, validation. Now, also, database queries also, right? So, for example, knowing this, having this knowledge, which we'll learn in the next few lectures, can help if you have an IDE, a visual, a text editor, but it does not have your language, it could happen. Then you could add this feature. It's possible. Most normal strong editors, like for example Notepad++ or Visual Studio Code, right? There is some specific language, right? you could add support, the syntax highlighting and syntax checking to this your editor, right? And actually, and it will work, right? So, also for document typesetting, LaTeX, right? Also, you know, it's using a formal grammar. So, again, so how does when we have a programming language, so let's go back a little bit. We have source code, right? Where do we end up? At machine code, zeros and ones, right? So again, so there's going to be multiple steps. The first step is going to be sort of like a pre-processing, which is usually in some language, not all of them, right? Today we're not going to look at this in detail, but macro expansion, you know, some copy replace, basic, essentially, you know, file inclusion, conditional compilation, right? As we've seen in our C++ course, you know, includes, defines, and so on. Then you have this lexical analysis, lexing. So what happens there? We generate tokens, right? Valid tokens, right? So what's a token? It's like a building block, like a Lego block, right? What, like, say, is number 5 a token? Yes. 55, also probably a token, right? 55, 9,000, also a token, right? So basically, at this moment, you sort of group the characters together, which make up like the most atomic, the smallest unit possible, right? So we don't want to, at this stage, we don't want to stay at individual digits. We want to have the digits combined into numbers, right? We also want to end up with variables and so on, identifiers, right? We don't want single letters. If we have single letter variables, that's fine. But we want also, if you have multiple letter variables, we want to end up with a token which represents single, 5-letter variable. Again, at this moment, we don't know it's a variable, of course. We don't have the semantics yet, right? That comes later. And then we get to the syntax analysis, which we're going to talk about today. That's our goal for the next lectures, this lecture and the following lectures. So we want to convert these tokens basically into this parsing tree, right, which represents the structure of the code, right? So to do that, we will need to have some formal notation again. So the BNF and eBNF is what we're going to be looking at, right? But there are other ways of doing it. And then afterwards, we have semantic analysis, right? We figure out actually whether things actually make sense, right? Maybe there's, whether if you have a correct number of arguments for your function, whether you have did you declare your variables? You know, if it's Python, it's not a problem, but for most languages, you need to declare your variables, right? Just like eating your vegetables, you need to declare your variables, right? So, and then usually what happens is something called intermediate code generation. So it is sort of like an abstraction, right? So sort of like a middle code, right? It's a code which does not depend on your operating system, right? It lets you specify some further optimizations for specific targets, for ARM, or for x86 Intel AMD based machines, or maybe, I don't know, MIPS machines or RISC machines. So different CPU architectures, right? So that comes later, right? And in this course, we don't really want work. We're not going to go that deep, actually. So this is just showing you the big picture, right? And eventually, of course, we have optimization. Then we have code generation, and then towards the end, we'll have linking, right? Like in C++, we have to link with other machine code files, dynamic linking libraries, for example, right? And we want to end up with a single executable if you're doing a compiler, right? So now, again, what happens here, right? It's whether it's compilation or interpretation, right? Again, by now compilation, you get whole machine code, right? On interpretation, you have some code, and you sort of it happens, line at line, basically, right? That's the basic idea. But usually, of course, there's some sort of hybrid approach, right? So, again, we don't need the code today. But again, our friend factorial program, right? But now, let's go back to our syntax. So we assume we have generated these tokens, right? So we could have a concrete syntax, basically, right? So here's our factorial code. I think by now you all know what it does, right? You have it's a recursive function, right? But again, at the moment, whether it semantically makes sense. It's whether your programming language lets you do recursive calls. This is not really part of the syntax to do. We just want to say, does this make sense? So we have this. We have to define, right? Whether that's valid, right? Can you use that? Huh? So we'll need to come up with some ways. Also, we'll need to define that there's after define, there's space, right? And we have to let some sort of function naming, right? Some sort of what makes a valid. So what's valid here? It certainly looks a valid code. Lowercase letters, that's valid, right? And then you have parentheses, and you have some sort of variable name, right? Argument name, right? Parameter as well, right? So a parameter n, right? Again, whether it's used here, whether we're using some other ones, that's not part of the syntax checkers, right? Whether it's actually being used properly, right? So this is just for syntax. But we know there has to be indentation right? There has to be indentation here, right? So for Python, you will want to have a token for indentation if you're coming up with the syntax, right? So keywords, right? So this is a concrete syntax, right? But afterwards, most normal programming modern languages will have this will abstract this, right? And will come up with something called abstract syntax tree, right? So there's going to be, say, okay, yeah, there's a function definition, right? Factorial argument, there's if-else node, right? There's condition node. If n is 0, we return, right? So basically, this abstract syntax, it doesn't really worry about this, concrete syntax rules. It just says sort of like it's higher, more, I would say, standing higher on the mountain of abstraction definition, basically, right? So again, today we deal with concrete syntax because that's what we see when we write our programs, right? We deal with concrete syntax, right? That's what we are trying to come up with some ways of defining it, right? But we'll also know it, of course, if you're writing a full-fledged programming language, a tooling, you will need to deal with abstract syntax, right? So usually, again, there is a step when you convert this concrete syntax into abstract syntax, right? Okay, but now that we have this stuff, we find this. So how would you? Let's say you write to make a new language, but let's say you want to write a language, but for now it's really simple language. It doesn't have loop. It's not really a programming language, just an arithmetic language, just for adding numbers together, right? So how would you make a specification for this language, which lets you add integers, right? Only integers. And what are valid symbols? Integers. It's a language for calculator, let's assume, right? Something like your one of your homeworks from our last semester, right? You remember parser, right? You did your parsing, right? So how would you define a valid language? What's a valid, this arithmetic language? So maybe I'll probably use let me open Paint again, right? So you know what I'm talking about. My favorite.
You should define some grammar.
Yes, that's exactly what I'm leading to. But let's say we want to say pi plus 2000 is okay, right? Would be okay, right? But for example, this. Oh, I want to change color to black. Let's go back. What is the back? Oh, here you go back. Yeah, I can go back. Okay, so this, oops, again.
You should change the color one to black.
Oh, color blind. Oh, yeah, here we go. Yeah. I'll make this red. Okay. So yeah, for 5.3 plus, I don't know, 10, not okay, right? So, 5 minus 30 is okay. 5 times 30, right? Not okay, right? Can I do this? No,
the color is for the infill of the.
Oh, yeah, it's for fill color, right? It's fill. Yes. Yeah, so I need to do this, right? Okay, so this is okay. Not okay, right? Right, not okay, right? So not acceptable, acceptable, right? That's the word, right? Right, so I'm just lazy. I say, okay, not okay, but say accept, accept, right? right? So also we would want to do again, I'll do this here again. So something like, 5 plus 10 minus 3 plus 9,000 would be okay, right? But something like 5 plus 10 minus 3 plus, right, would not be okay. This, right? So okay, or accept, accept, not acceptable, not okay, right? I'm being very informal at the moment, right? So, and again, so while this, would not be okay, right? So, while this would not be okay, right? While this would not be okay, yeah, not okay, right? Right. So, so we need some way again. So, but of course, the possibilities are endless, right? People write all kinds of things, right? So we need some things to accept, right? Say, okay, this is valid syntax. So you're writing basically, you would be writing rules for your ID, this arithmetic language, right? Which is only has plus and minus, right? And integers, right? But letters are not okay, right? So how would we define this? So we could sort of like, we could say, okay, this. Let's think about this. Like again, we don't know. Assume we don't know formally. Some of you may already know some ideas. Maybe some of you read the materials. That's fine, right? But how would you come up with this if you didn't really know anything yet, right? I don't think it's that hard, right? I'll do another paint. So what makes it valid? So we want basically say, okay, so digits. So this would be a rule. Number. We'll call this description basically, right? Maybe I'll use this basically. Number, right? Okay, right? So, and I would say expression no, but operator, right? Number, operator, number, right? Would be okay, right? Basically, right? Now, this stage, right, we could say we need some sort of way, since this would be very limited length. If we leave it like this, right, and we say, okay, operation is basically, plus or, I'll call it, or minus, right? Right? A number is basically, again, and this I'm not formal yet. I know it's not formal. Basically, say 0, 1, any, I'm using sort of regular expression rules, right? Sort of like 7, 8, 9, right? We use, something like this, right? And I'll do regular expression, not star, but one or more times, right? What's the symbol in regular expressions for one or more times?
Star.
No, what's the other one?
Plus.
Plus, right? Yeah, plus here, right? So not star. Star would be you have nothing. That would be kind of dangerous. You don't want nothing, right, as a number, right? Yeah, notice not star, yeah, not star, because empty is not allowed, right? Right. Now, we could also have space, right? If you want to be really, this here, we can, of course, some tokenizers ignore space, or we could add we could easily add the space. It's any white space characters, one or more, right? At least one again, right? Okay. So that's, again, it's not completely formal, but you see the idea. But then we'll need some way of, at the current stage, we don't have a way of getting more than one operation, right? We need some way of producing more than one, right? Because we have like, like the, where's the other one? This one here, like this, this is okay, right? But it includes four numbers and 3 operators, right? We need a way to build it up. So some sort of way of looping in, right? But in defining language, you're not going to say, okay, a loop, right? We could, we could come up with, you could come with some new way of describing it. Maybe it will be, take the world by storm, right? But the way it's done historically, it's you come up with these production rules, basically, right? How you build up, you come up with these sort of say non-terminal symbols, meaning you have again, you come up with something called expression. For example, here you could think, okay, this is an expression. What's an expression? We come up with some more things which are not, how should I say, not finished yet, right? Non-terminal, right? So some way to we need to right need to add more longer add longer expressions, right? Expressions. What's happening there? No, nothing's. All right. So there are other ways of doing. So there are a couple of ways of doing it, right? So let's see. We'll get to that. So that's the problem with standing we are facing. So we get to Noam Chomsky again. Noam Chomsky is still alive, right? He must be over 90 right now, right? So again, he was working with classification of formal grammars, right? So grammars, right, could be. He was not a programmer, right? But he was talking about human language, right? And he came up with this hierarchy, right? And it's important in linguistics and also for us in computer science, right? How we can describe syntax of a programming language, right? So context-free languages, right? So type 0, any language, right? So we don't really use that. Context-sensitive language, right? Context-free. So this is a type 3. So what you should realize that this is not the grammar itself is not a full Turing complete language, right? It's not a Turing machine, basically, right? That's reserved for this one here, right? For higher. So to describe a programming language, we don't need a full strength programming language. I mean, we could, right? We could write another, we could use another programming language to define a new programming language. It's possible. I mean, again, if you're writing an emulator, of course you'll do that. But at this stage, for the syntax, right, we use something called context-free grammars, right? So thing is, we could actually, sometimes we can get away with regular grammars, right? The thing is, not everything. So some formats, we can specify using regular grammar, right? For example, this my paint job, right? So these we could actually get away with the regular grammar, right? But for actual full-strength languages, we will need context-free grammar, actually, right? So that's a hierarchy, right? Actually, right? So concrete syntax specifications. Again, I was hoping we will get to the break. We are I'm going a little bit faster than I would like to, but I guess we can already start. But so we could also think of there's another approach we could use for the specification, and I'll show you how it's done. For example, JSON. Let's look at the JSON specification. Right, let's go JSON.org, right? Right. So this is called, well, I would call them railroad diagrams, right? This is a definition, right? This defines the syntax of a JSON, not programming language, right? It's basically object notation, right? How JSON should be, right? These diagrams. That's also a completely valid way of specifying some language. It's just that for most languages, we will not be able to specify something like this. I think it's maybe more visual. So we will need to define, for example, you can say what's a number. You can see I'm going to steal from here, right? A number is basically, digits, right? And there should be a loop basically somewhere here, right? And it's looping, right? Possibly to loop, right? So we can use this, right? So digit Is there white space? What's a white space, right? So that's why they call them railroad diagrams. It's kind of like this bunch of roads going through, right? So white space is defined as bunch of at least one or more white space character, right? But just in a more formal but a visual way, right? So let's see if I could write this railroad diagram, right? For digits, right? So I can steal it from here, right? And I'm just going to skip. So digits would be basically this, right? Well, we have digits here. Actually, we don't have digits here. Basically, it's kind of like skipped, right? So white space, right? So value, right? Any of these, but we don't have loops. So let's see if we can see a loops here. Object, right? What makes for an object, right? Objects need curly spaces, curly braces, right? Right. So how could I? Let's see number. Do they have number specification here? String. Okay, yeah, number, right? So this is optional. Minus is optional, right? Let's see how this is done, right? So number is optional. I mean, minus is optional. Plus is not. There's no plus in at least not in JSON specification, right? Then, well, minus 0, right? Is this actually allowed? Let's see. Fraction exponent. Again, we're not dealing this moment. We don't have fraction exponent, right? Because we're just dealing with integers, right? Integer definition. We just have basically digits. Keep going, right? We define a digit, from 1 to 0, right? Notice here. I guess you need. I'm trying to see what this 0 does here. Does this mean that minus 0 is not allowed? I think it seems like it's allowed, right? Minus 0 is okay, right? So you can proceed. Or do you need 1? So, oh no, okay, yeah. So minus 0 is allowed, right? We could try this in Visual Studio Code. We have Visual Studio Code, right? We could try, see if it works. All right, let me see. Do you have Visual Studio Code? All right, code. I think it was installed here. I saw it. Yeah. I'll make a new file somewhere. I'm just not even sure which file. I'll need to open a folder somewhere. Okay, this status final. Okay, that's good. That's a good folder to open. Right. But yes, I trust the authors, and I'll just put folder here, JSON, like so. Basic JSON, right? Right. So 0, it's valid, right? So let's try minus 0. It's valid, right? So how about minus b? That should not be valid. Yeah, that's not valid, right? Because there's no minus b in specification, right? So that's not valid JSON, but minus 0. So how about let's try here. So plus 0, is that valid? It's not valid. So plus 0 is not valid JSON, right? Why? Because it's not in this particular specification, right? There's no place. If you want to have plus, right? You're not allowed here, right? So looks like so minus. If you write minus, you can write any digits, 1 something. But notice here. So if you write 0, right? So 0 apparently is also not valid. Let's try this, right? Let me make this bigger. Can you make this bigger? Yeah. All right. So minus bigger. So 0. Again, not valid. 3 zeros, right? In JSON, it's not valid. Oh, come on, right? Not valid. Big red. Because why is it not valid? Because the grammar rules built into Visual Studio Code, right? They know this is not valid JSON, right? So, but 5000 is valid, right? Again, some of you might not know that JSON actually a single. So by these rules, the JSON. A single number is valid JSON. Most JSON files are not going to be a single number, but technically it's valid JSON. Technically, right? A single number, right? And again, so point something, that's also valid, right? But if you write a point, this means you need to finish. That means there is something afterwards. You can't just leave it hanging. So how is it defined? Here, we can see here. Let me make smaller. Come on, right? So if you write a dot, you need a digit, right? Any digit. So this means that you can write 0, right? That's valid, right? B, not valid. Valdis, not valid, right? Okay. So constantly, your editor, when it's checking again, any programming language, right, there's going to be a syntax checker which is going to be checking whether these rules are valid. Okay. All right. So the railroad diagrams here, right, they are not really, I would say, you can generate them if you want from this formal rules, but you don't, it's for anything more, more complex, it's going to be pretty hard. It's going to be pretty hard to actually generate something complex. Again, you can see what a string is, right? What's a string? Let me make it smaller. Come on. Come on. What is this? Oh, yeah. It's kind of it's a little bit. So you have to go really, really, very atomic, but very low level, right? So value here is basically a whole bunch of different things, right? There could be some white space, right? Object, again. But let's not deal with those. What's a string? So any code point except escape, right? But if you have an escape, then you can use one of these, right? Quotation marks, any of these, right? You can use 4 hex digits, right? So these are all valid. So this means that you are not supposed, let's try this, right? Let's try a string. So again, valid in a JSON, like val, this is not valid JSON, right? That's not JSON, but this is going to be val, this at RBS. This is valid JSON. It's a string, but it's a valid JSON. And why is it valid JSON? Because the rules say so, because JSON starts with a value, basically, right? So value, right, it could be anything, right? It could be an object, it could be an array, but it could be also a string, right? So, all right. So after the break, we will look at the actual formal ways that, again, during 1960s, 70s, well, computer scientists said, okay, this is the best way to do it, but there have been some modifications since. Let's take a break till 3. Yeah, let's take a break till 3. And we'll finish this actual formal specification. Any questions so far? No.
No.
Pretty easy so far.
Yes.
All right. Very good.